everyone. Natalie Givler here. I am the Wallhopter Product Manager at Allied Machine and Engineering, and today we're going to talk about our boring kits. So within our Wallhopter boring kits, we have a couple of different options. First off, for your reference on our website, we have a really nice kit flyer that outlines all the different options, all the different configurations of kits, and all the different item numbers, really everything you need to know about what we have to offer. So from VarioBore to DigiBore to PrimeBore, all the information you need on kits should be included here in this flyer. So today we're going to focus on the PrimeBore kits. There's really only one configuration of kit available. We have that in both inch and metric, which really the only difference there is that the boring head will have either a Vernier dial for inch adjustment or metric. The other difference is going to be either a Form 101 80-degree diamond insert or a Form 20 triangle insert. So that's just going to change the insert pockets that are in the boring heads and the insert holders and things like that. So one thing to mention about the PrimeBore kit is that this does have the widest range of capabilities compared to any of the other boring kits. So the full range of this kit goes from 6 millimeters up to 128 millimeters. So a pretty wide range that we have there. And within the kit, it's going to have all the different components necessary for building each of those assemblies, as well as all the wrenches and things that are required to put all of those together. So today we're going to do 3 different demos, and I'm going to show you how to set up 3 different types of assemblies as well. So the different diameters that we're going to do today are 1/2 inch diameter, and then 1 1/4 inch, and then 3.5 inch diameter as well. So we're going to kind of start small and then work our way up from there and see how we can put those assemblies together, and we're also going to run them in the machine. So when you order the boring kit, we're going to kind of take a look here at what's going to be inside. You get the operating manual that tells you everything you need to know about this boring head, how to set things up, max RPMs, all the different tightening torque requirements and things like that. So you're also going to have, of course, the PrimeBore boring head. You have a serrated slide, 2 insert holders, you have a coolant delivery piece, which I'll get to in a moment. You have a serrated boring bar and then 3 standard boring bars. Then you have a couple wrenches included as well. This Allen key is going to be what's used to put all the different components together. These 2 are really just for putting the inserts into the insert pocket themselves. So this is kind of going to be kind of our go-to adjustment wrench for today. So our first assembly is going to be a pretty simple one. At 1/2 inch diameter, really all that we need is our boring head and a boring bar. So I'm going to set that here. And the boring bar that we need, this is the second smallest one in the range of this kit. So like I said, this goes down to 6 millimeters. This boring head itself even can go a little bit smaller than that. So even the smallest one that we offer in the product line is not included in this kit. But again, right now we're headed for 1/2 inch diameter, so this is the bar that we're going to be using. Now, just kind of looking a little bit about this PrimeBore head, you see you have your Vernier dial, you have your clamping screw, so that's what's going to tighten down our slide so that it doesn't move when we're running. This is our screw for tightening anything into the bar hole. And then, you do have some screw holes along the outside. Those are for balancing screws. If ever you wanted to kind of put some weight on either side to make the assembly a little bit more balanced and offset any kind of positioning of the boring bar or insert holders. So we're going to take the boring bar and we're going to line up the flat on the bar with the screw hole. And then you can see that this is a closed flat, so we want to make sure we put it down in far enough to go beyond that. It's not going to really bottom out, so if I were to let go of this boring bar, it would just fall all the way down through the boring head, so I do have to hold on to it. I'm going to tighten this down. Now I'm just going to go hand tight for right now. But if we were going to be putting this specific assembly in the machine, we would want to tighten everything down to the desired torque, which for this tool, and it's also written on here, is 7 Newton meters. Pretty much everything within this tool is going to be tightened down to that 7 Newton meter value. So other than that, really all we would need to do with this assembly is assemble our desired insert into the insert pocket, tighten that thing down, and then we would rough set it in the presetter and we'd be ready to run. So I'm going to go ahead and turn it over to Rob, and he is going to get us going on the demo.
Hi there, my name is Rob Brown. I'm the engineering trainer here at Allied. And the machine we're going to be running on today is a Mazak VCN 575C vertical machining center with 30 horsepower spindle. And we have the coolant set for this application at 400 PSI, which is about 27.5 bar of coolant. The material we're going to be running today is 304 stainless steel. It's 160 to 170 Bernal in hardness. And as Natalie pointed out, we're going to run 3 different diameters for you today. But the first one we're going to do here, we're aiming for a finish hole size of a ½ inch or 0.500 inches, which is 12.7 millimeters. We're going to be running with an F101 insert for all of the application because the insert pockets are all the same. We're using a geometry and substrate that's going to be good for stainless steel. We're going to run the 199 geometry and the WHC 114 substrate and coating. The corner radius on this tool is going to be a 2 nose radius or 1/8 thou. And the way we're going to set this thing up is for the first part of this, we're going to act like we're just setting this drill up for the first time. So what we've done is we set this up on a presetter, but we intentionally set it undersize on the presetter to about 480 thou. So it's about ½ millimeter or 20 thou undersize. So whenever we come in to do our test cut, we're going to cut it at that smaller size because I can always make the hole bigger. Get a bore gauge, measure the size of the hole that it produces with the bore gauge, and then make my adjustment on the tool and then go back into that same cut again. So the reason why we're going about 20 thou undersize is because we want to make sure that whenever we come in to do that secondary cut to the proper size, that we have enough material there for the boring tool to do its cut properly, because I have to have enough depth of cut for the insert to get past the nose radius to be able to cut properly. So once again, we're running 304 stainless steel. Dave, if you want to go ahead and get ready and go. The speed and feed this tool is going to be running is 450 surface feet a minute at a feed rate of 0.0026 inches per revolution, which in metric equates to 137 meters a minute or 0.066 millimeters per revolution. Okay, so we went a depth of cut of about 3/4 of an inch deep. Okay, so now what we're going to do is we're going to get the bore gauge and we're going to go and gauge the hole that it produced, because remember, it should be somewhere in the neighborhood of about 20 thou undersize. Okay, so we're going to make that a measurement, and then based on what that measurement is, we're going to see how far away from the 500 thou that we are. So the hole measures right at 480. Okay, so what we're going to have to do is we're going to have to make a 20 thou adjustment exactly on the PrimeBore to produce the end hole size of a ½ inch. So that's what Dave's going to do now. The first thing he has to do is unlock the spindle, which is what that is, and then he's going to do for the PrimeBore, 1 full turn is 20 thou. So he's just going to do 1 full turn on the spindle there, and bring it right back around where he started off. Because remember, this is a Vernier scale, so he's going to move it exactly 20 thou. And then he'll lock the spindle back down, and we'll go and open up that hole. But remember, we did that 20 thou oversize, so that way we make sure that we still have a proper depth of cut with this tool when we come in to do this second cut, because if we didn't have that proper depth of cut, it can have a negative effect on the outcome of the hole size, and we can end up with a bad reading. Like we do a 5 thou adjustment thinking that we're making the hole 5 thou larger, but since we're cutting with nothing but the nose radius, what ends up happening then is that it actually cuts a little bit undersized. So Dave, you want to go ahead and do here? So we want to make sure we have enough depth of cut there that we actually get onto the flat of that nose radius. Okay, so just like before, we're going to come in, go about 3/4 of an inch deep, running 450 surface feet a minute, and 0.0026 inches per rev, which is 137 meters a minute, 0.066 millimeters per rev. So now what we got to do is open it up, we'll get the bore gauge, we'll measure the hole size, and see how that compares to the goal of hitting 0.5000. Okay? So the hole size is 0.49950, so it's off by 0.5. Okay? So in the real world, we'd be ready to go, or if I need to make another small adjustment to it, I couldn't go back into that same hole again. I would have to go to the next hole after I made that adjustment, because that 0.5 isn't enough. So we're going to turn it back over to Natalie so she can talk about what we're going to do next, and we'll see you in a minute.
All right, sounds good, thank you. So we're going to move on to our next size assembly. So like I said before, we're going to kind of look at kind of the mid-range of the capabilities of this tool. So we're going to be at 1.25 inches. So our setup is going to look a little bit different. Rather than just using the boring head and a boring bar, we're going to use a boring bar that has serrations on the top, and then we're going to put an adjustable insert holder on the top as well. So again, over here, kind of looking at the components that we're going to need, we need the boring head and the serrated boring bar, I have right here. And then we're going to need an insert holder as well. Now, in the kit, you're going to see that there's two different insert holders. There's one that's quite a bit larger than the other. The bigger one is for the serrated slides. The smaller one is for the serrated boring bar. So we're going to save that one for later. That will be used for our last demo. And again, we're going to use the same Allen key that I used before for the boring bar. Now with this one, it's a little bit easier. You just want to line up that mounting hole with the mounting screw. And then this one, of course, is going to bottom out on there. And then we will feel that, grab that mounting hole. And it is tapered, so like I said, you'll kind of feel it, find its happy place. Tighten that down. Again, hand tight for now, but 7 Newton meters would be our target. We're going to remove this. Now, you can see that there's a 0 indicator here on the serrated boring bar. We're going to line that up with the serrations on the indicator lines on the insert holder. A little bit of a glare, but make sure you guys can see that. So that'll allow us, if we don't have a presetter, that will allow us to at least get close to the size that we want for our test cut, and just kind of line it up that way. Now you do have a little bit of adjustment within this insert holder, so you can see, you know, that kind of gives me my starting range. And then you have even more adjustment within the vernier dial as well. So this one too, 7 Newton meters is what that's going to be tightened to. And then we just have to put in our insert, and then we would be ready to run with this one. So again, I'll turn it over to Rob for our second demo.
All right. Thank you, Natalie. So what we're going to do for this one, once again, we're going to go back into the, it's the same material, 304 stainless steel, 160 to 170 Bernal. But this time, instead of doing a 1/2 inch diameter as our target size, we're going to do 1.25 inches as our target size, using the setup that Natalie just put together for you there. So just like before, we're going to run this, we're going to set this up on a bench, intentionally undersize. So just like before, we're going to take it over to the presetter. We're going to set it 20 thou under the finish size that we want. So instead of setting it to 1.2500, we're going to set it to 1.230, and then do our test cut, because once again, we got to have enough stock left to do that finish cut that we want to make sure that we get a good cut out of that, so we end up with an accurate size. Okay, so just like before, 20 thou undersize. So we're going to run into this material. It's using the exact same insert that we just had, that 02 nose radius, 199 geometry, 114 substrate and coating. It's an F101 insert. So the speed and feed is going to be the same, 450 surface feet a minute, 0.0026 inches per rev. And in metric, that's 137 meters a minute and 0.066 millimeters per revolution. So Dave, whenever you're ready, let's go ahead and go. Okay, so once again, what we're doing here is we're going to come in, we're going to cut in an undersized condition, right? So we're going to take this hole. Now the pre-existing hole size, just for reference, is 31 millimeters. So we're going to open it up, going about 3/4 of an inch deep here, just like we did with that 1/2 inch hole. Okay, And then we're going to come in, we're going to measure it to see how that equates to the 1.230 that we wanted. And then knowing that that was 20 thou oversized, whatever the difference is, that's what we're going to do that difference in the adjustment of the tool to get us up to the 1.250 inch diameter. Okay, so it should be 1.230, and it comes out at 1.2318 and 50 millions. So Dave will go and put in the calculation to see how much of an adjustment that he needs to do. It's going to be about just under 18 thou, or just over 18 thou rather. Okay, so his adjustment's going to be 18 thou 2/10 is what he's going to do for his adjustment. So it's nearly one full rotation of the dial, because remember, one full rotation of this dial, since this is an inch PrimeBore, is 20 thou. So he's going to go just shy of one full rotation to get it set up. Now, this is where it takes, you know, kind of a keen eye and remembering where you left off, because with the Vernier scale, of course, you're going to want to go the alignment that you had before, and you want to go 2 hash marks behind that and move that up to get that 2/10 that you need to get it to come out even. Okay, so it is a little more complicated, but from a precision standpoint, the outcome is going to be just as precise as what you would get with a digital readout. It just adds another layer of complexity to it, or complication, because you got to make sure you have all the right hash marks on it. Okay, so it turns into having the potential to do human error whenever you do it, because of the fact that, you know, you're going to have to rely on remembering where you were and where you're going. Okay, so now that he's got the adjustment made, he's going to lock that thing back down again. And then, just like we did with that 1/2 inch hole, we're going to go back into this same hole, because we have enough stock left in the application to allow for a nice engagement between the boring tool and the material. So we get a good cut out of it, and then we'll measure the outcome. So Dave, whenever you're ready, let's go ahead and cut this one. So once again, 450 surface feet a minute, 0.0026 inches per rev. Metric equivalent would be 137 meters a minute, and 0.066 millimeters per rev. We're only going to go about 3/4 of an inch deep with this, and then we'll gauge the size that it comes out to. Okay, there we go. So once we get the all clear here, Dave will get his bore gauge out again, and we will go check the size and see how we did in relation to coming out at 1.25 inches, which, by the way, in metric is 31.75 millimeters. Okay? So he comes out at 1.2501, so his accuracy is within 1/10. So good job, Dave. All right, so we're going to turn it back over to Natalie and do one more setup here, and we'll see you in a minute.
All right. We are going to set up our third and final assembly and demo. So our final diameter is going to be 3.5 inches. That's kind of our finishing target. So, you know, again, this kit specifically goes up to 128 millimeters. The capability of this tool itself will go up to 205 millimeters. So, you know, we're still not up there to the full capabilities of the tool. It can go much larger. So the capabilities that we have here in the lab only allow us to go so large with the material that we have. So we're going to do 3.5 inches, but again, we could go much larger if we wanted to today. So for our assembly at the larger diameters, we're going to need a couple additional components. So we have our boring head. You have a serrated slide, and there's a couple screws in there that I will get to shortly. You need this coolant delivery section. So what this is for is this is how we're going to get coolant from the boring hole right up to the cutting edge. So that's going to kind of plug in from the back, and that's what's going to plumb our coolant right to the cutting edge. Then we are also going to need, like I said, we have 2 different insert holders, but we're going to use the larger one that is in this kit, and then we're going to need our adjustment wrench. So when we mount the coolant section, there are 2 different position options. So we can either mount this, it's kind of difficult for me to show, it can either go this way, or if you rotate it 180 degrees, it would go this way. Now I'm going to show in our operating manual, I'm going to show one page here. So depending on our finish diameter, that's how you would determine how this is set up. Now at the smaller ranges, you're going to have the coolant nozzle facing one way, and then at the larger ranges, you're going to have the coolant nozzle facing the other way. Since we're going to 3.5 inches, we could really assemble this either way. But you just kind of want to keep in mind that if you're on the smaller end or the larger end, it is important that you are setting that up properly. So refer to this operating manual. That's really helpful when you're getting into the technical stuff. All right, so I'm going to hold on to this. Really, you know, I have a little bit of fingernail, so that makes it kind of easier to hang on to it. Otherwise, like I said, it would drop all the way through the center. I don't quite have that positioned right. You can, like I said, you can feel it. There we go. All right. And then I would tighten that down to 7 Newton meters. And then we're going to line up. So you want to look for these triangles to line up properly. And then there we go. We have that on. Now these are the screws that we're going to tighten down to get the slide onto the boring head. Now if I would have had that coolant delivery section flipped the other way, I would be using these other 2 screw holes to position that, because this slide would be positioned out a little bit further to get us to the larger diameters of the range of this setup. So I'm going to go ahead and tighten those down. Go. Take this out. And here, you know, we have 2 different options. It's not going to change how it mounts onto the slide, but it does depend on where we put our screw hole. So you have adjustment similar to the serrated boring bars. You have a lot of adjustment within the slot on the insert holder itself. But then, you know, you have an even wider range if you move it within the other screw hole. So we're just going to tighten this down. And again, you know, you want to keep an eye out on the indicator lines and the indicator hash marks on the tool. And, you know, here it would be very obvious if you had it positioned wrong, because the insert wouldn't be facing the right direction. But if you ever are in doubt, look for those lines. So now we have coolant going right to the cutting edge. We have our triangles lined up, so we know we have this positioned properly. Next thing we would need to do is go in and tighten everything down to 7 Newton meters. We would put our insert into the insert pocket, and then we'd be ready to run. So we are going to finish this out with our final demo. So I'll turn it over to Rob once again.
All right. So what we're going to do for this one is we're not going to do the undersize over finish size for this one, because unfortunately I don't have a bore gauge that goes out to 3.5 inch diameter to be able to measure that. We do have the ability to use 2-point gauges, but that gets a little bit more complicated to try to show you on as a video. So what we're going to do with this one is we're just going to go and cut this one, but then whenever we're done with it, we're going to take it out. And what we haven't done yet is we actually haven't checked finishes yet to check to see what kind of an RA finish we get with this. So once again, what we're going to be cutting here is 304 stainless steel. It's 160 to 170 Bernal in hardness, using that same insert that we used for the other 2 applications that we already ran for you. So the speed and feed is actually going to be the same. It's going to be 450 surface feet, 0.0026 millimeters per rev, which in metrics 137 millimeters per minute, and 0.066 millimeters per revolution. So Dave, whenever you're ready, we'll go ahead and run this one. And once again, what we're going to do is we're going to cut this to a 3.5 inch diameter. But what we're going to pay attention to on this one is the finish that we produce. Okay, so once again, this is running at 450 surface feet per minute, 0.0026 inches per rev. We're going to cut a little bit deeper with this one, since we're going to be doing the profilometer on. I want to make sure that we have enough length of cut on that to be able to get a good reading with the profilometer. So it might take an extra second or two to get this thing bored to depth. But you know, and remember, this is 304 stainless steel, about 160, 170 Bernal in hardness. And whenever that's done, we'll take this part out, we'll put it in the profilometer, and we're going to check to see what kind of a surface finish that we get out of it. Okay? So, you know, the thing to remember with what we've seen so far today is we're using the same base for all three of these different diameters. So we started off at a 1/2 inch diameter, then went to 1 1/4 inch, now we're doing a 3.5 inch diameter, just simply by changing the accessories that go on that boring head. So that's, you know, kind of the positive of the PrimeBore style of system, is that you buy one body and you get to do a wide variety of different diameters with that one body. So it gives you the ability to do like in a small batch applications and things like that. It gives me a lot of variability in the sizes that I can do. But what we're going to see here, you know, I already saw that it does a really good job of doing size. Let's take a look at what it does from a finish standpoint. Okay, so we're going to come over to the profilometer here and put that on and check the RA finish on that. So this will only take a second or two, and you know, once we get this reading, it's going to give us an RA inch, because we're reading this in inch. If you're wanting to know what that is in the metric equivalent, you would just divide that number by 40. So for example, like if it comes out with a 20 finish, that would be an RA inch, it would be a 0.5 RA metric. Okay, so what we got is a 16.5 inch, which actually comes out to about a 0.4 metric RA finish, which is quite good. So let me grab the piece from Dave here, and we'll kind of bring it up under the camera so you can actually see visually what the finish looks like. So if we can, there we go. So you can see the quality of the outcome that you got. It is a really nice finish that it produced. Okay, very nice and smooth. And once again, whenever we measured it, it came out to a 16 RA finish. So that concludes the demos that we have to run today. So Natalie, if you have any closing comments, come on back and we can have a conversation. Thank you very much for your time.
Yeah, thank you. Thanks everyone for tuning in today. You know, we do offer many other types of kits, other types of boring heads, many other different products. So just to kind of, you know, focus on the PrimeBore tool, this is a really good kind of entry product into the product line. It doesn't have all the digital bells and whistles and self-balancing features and some of the things that our other tools have, but it is a very precise tool, very accurate, good quality, but has a very wide range versatility like Rob touched on. So, you know, this kit especially really gives the range that, you know, maybe smaller batch quantities would really benefit from. So that pretty much concludes things for today. Again, thanks everyone for tuning in. For more information on what we have to offer, you know, seek out this flyer on the website at allymachine.com, as well as our other literature, catalogs, and other content on there as well. Thank you.